Hi guys, so today we'll be solving this problem called find the prefix common array of two arrays. Let's read it. You are given two zero-indexed integer permutations a and b of length n. A prefix common array of a and b is an array C such that C of I is equal to the count of numbers that are present at or before the index I in both a and b. Return the prefix common array of a and b. A sequence of n integer is called a permutation if it contains all integers from 1 to n exactly once, right? So let's understand this. So we've been given two arrays. So 1, 2, if you see the first example. So the first array is 1, 3, 2, 4, and the second array is 3, 1, 2, 4, right? And we need to return the common prefix array, right? So which means uh, a prefix common array of a and b is an array C such that C of I is equal to the count of numbers that are present at or before the index I in both a and b, right? And basically what it's saying is that we need to return one more array which denotes the count of common elements till that index, right? So it says count of common or count of the number that are present at or before the index I, common numbers, right? So basically till if I take this first example, so till um, till the first index, I just have nothing in common, right? So I just have zero here, right? Till the second index, I have 1, 1, 3, and 3. So which means I have two elements common, right? And for the third index, I have 1, 3, 2, right? So 1, 1 is here, 3, 3 is here, 2, 2 is here. So I have three elements in common, right? And then the last, I have 1, 1 is here, 3, 3 is here, 2, 2 is here, 4, 4 is here. I have four elements in common, right? So that is my answer, which is the common prefix array of these two arrays. And that is something that I'll return, right? So there are quite a few approaches, like actually, like you can just brute force this, you know. How can you brute force this? So basically just going to go till, like I'll just iterate from left to right, and I'll also iterate again, for let's say I'm at index 2, I'll iterate the A and I'll iterate the B, and I see what are the common elements in both of them, and I just count that. So that will give me something which is, you know, um, like I'll have to maintain like two loops and probably do that for it. So I think time complexity is O of n square for it, right? Right. So that is one approach of solving this problem, right? There is another approach, which basically takes the space, and it's going to be something with sets, right? So what I can do is I can count the basically I'll just iterate through the array, right? And I'll maintain two sets. So set 1 for A and set 2 for B, right? And I'll keep on putting the elements in the set, right? And let's say I'm at index 3. So I'll just iterate through the set, and I'll check if there is any, if any, like if I'll put elements in the set 1, set 2, right? A and B elements, A in set 1, B in set 2, and I'll iterate through the indexes. And let's say I'm at index 2, so I'll just basically iterate through set 1 and see how many elements of set 1 are in set 2, right? And this will give me the count of the common elements between these two, right? And basically this is something that is like O of n squared still, like in the worst case, it's O of n squared, but still it is O of n squared, right? So yeah, that is an approach, possibly, right? But it has also space, right? So what is the other approach? So one is with hash maps. So this is the most optimized approach. So which we are going to solve in O of n. How? Let's see. So I have 1, 2, 1, 3, 2, and 4, and then 3, 1, 2, and 4, right? And I'll maintain a hash map, right? So what I'll do, I'll just go through each. So I'll go to 1, right? And I'll map it to 1 frequency because that's the occurrence of it. And go to 3, I'll mark the frequency as 1. Then I'll go again, right? Now it's 3. So 3 is occurred again. So now 3 is occurred again. So this is 2. And basically this one is occurred again. So this is also 2. So now whenever there is a frequency change of 2, right? Whenever I get a frequency of 2, which means that it's common in both the sets, right? And I need to just do a count plus plus, and I'll maintain basically a global count, and I'll just use that count to put it in the index, right? So here it's occurred twice, right? So all these elements have occurred. So two elements are common basically. So I'll just see, like, if, this index and this index, whatever the frequency of these basically elements is, I'll just do a count plus plus and add it to the final array, right? So let's go ahead. So we are on this end, and we have 2. So 2 is occurring twice again. So one time here, one time here. So now I know that it's 2. So I'll do count plus plus, which means then it's 3, right? Then I'm at 4. Similarly, the 4 case is also twice, right? So it will be occurring 4. You know, the 3 will add plus 1 to it and it becomes 4, right? So that is the idea. Let's get to the coding part in order to understand this a bit better. So first of all, what I'll do is I'll create a, a prefix array, which is basically going to store the answer, right? And then I'm going to create an unordered map, which is going to have basically the frequency of each element, right? And then I'll just iterate through the for loop, and it's simple. So first of all, if frequency element of a of I, right, is equal to 2, right? So this basically, this operation is also adding and increasing the frequency, right? So if it's equal to 2, then I know that I'll need to maintain a common count, which is basically going to count the number of elements which are common between two arrays till that index. So common count plus plus, right? And then it's frequency of element b of I equal to 2, then it's common count plus plus, right? And once that's done, once I've counted it, right, I'll add it to the prefix array. So prefix of I equal to common count. And that will keep on going till the end. And I just return the prefix array in the end, right? So that is the solution. Basically, I'll just maintain a map, and anytime I see the same element, right, I have the frequency equal to 2, right? And I do common count plus plus, common count plus plus, and I'll add it to prefix of I equal to common count, right? So let's run the code to see if everything is working fine. So yeah, one more thing, because of, if there were like duplicate elements, I couldn't have used the map, by the way. It specifically specified the sequence of an integer is called permutation. It contains all integers from 1 to n exactly 1. So basically, you are given two zero index integer permutations a and b of length n, right? So we have the permutations from 0 to 1 to n, and basically they are occurring only once, right? That's why I'm able to use the map. Otherwise, with duplicate, it wouldn't have been possible. Let's submit it. Cool, that's accepted. I hope you guys understood the problem. Thank you so much.